Deep beneath Geneva's surface, within the Earth, lies an extraordinary development of human ingenuity and an inevitable sign of both progress and peril. The Large Hadron Collider, LHC. It stands as a symbol of advanced scientific inquiry, enabling researchers to investigate the world's leading subatomic mysteries, including the discovery of the elusive Higgs boson, often referred to as the God particle. This groundbreaking accomplishment has captivated the global scientific community. Yet, as the well-known physicist Brian Cox has ominously suggested, the LHC holds an undiscovered potential that has raised questions and concerns. Could our quest for understanding have pushed us toward a dangerous and unpredictable future? Could we be heading into unknown territory, one that could defy our comprehension? Before we explore these unsettling possibilities, it's crucial to first understand the massive machine at the heart of the debate. The LHC. CERN oversees a formidable 17-meter ring of superconducting magnets, the largest and most powerful particle accelerator ever constructed. It stands as the apex of scientific achievement, capable of simulating conditions that mirror the beginning of the universe. This machine allows scientists to explore the universe's fundamental components. But with such enormous power comes the potential for dangerous consequences, perhaps even venturing into terrible and unknown regions. Founded in 1954, CERN has become one of the most prestigious research institutions in the world, with 23 member countries and an extensive network of specialists. While the LHC is its flagship project, it is just one part of a broader network of accelerators and detectors aimed at understanding the smallest parts of the universe. The LHC accelerates protons to nearly the speed of light, smashing them into one another in a way that emulates the energy conditions present at the universe's inception. The temperatures generated by these collisions are millions of times hotter than the core of the Sun. Meanwhile, advanced cooling systems maintain a super-chilled environment far colder than outer space itself. The LHC includes 1,232 dipole magnets, which steer the proton beams, 392 quadrupole magnets, which focus the beams just before they collide. Additional magnets increase the likelihood of particle collisions by applying tremendous force to the particles. CERN's goal is to collide particles with such precision that it resembles hitting two needles placed 6 millimeters apart. The accuracy required for this operation is staggering, and the technology behind it is unparalleled. The collider is housed in concentric rings deep underground, shielded from radiation to ensure optimal performance. The entire system is cooled to minus 46 degrees Celsius, colder than outer space itself. Inside the underground facility, there are 4 distinct detectors: Atlas, CMS, ALICE, and LHCb, each serving a unique purpose in studying different aspects of particle physics. These detectors act as large cameras that capture the impacts of particle collisions, with experts continuously analyzing the data for signs of the elusive Higgs boson. This particle is believed to be crucial for understanding the fundamental structure of the universe, revealing information about its underlying framework in numerous ways. Studying the microcosm of subatomic particles aids in our comprehension of the macrocosm of the universe, like solving a complex, cryptic puzzle. However, with every piece we fit into place, more mysteries emerge, reminding us that each discovery brings new challenges. The LHC is not simply a tool for scientific inquiry. It embodies human progress and our insatiable ambition to comprehend the fundamental forces that shape our reality. Yet, as we push further into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What risks lie in uncovering the unseen? Could our search for knowledge unleash forces beyond our control? A troubling revelation recently shook the scientific community. Brian Cox, a former CERN researcher and renowned figure in the field of particle physics, has warned that the LHC's mission to recreate a miniature version of the Big Bang, the very event that gave birth to our universe, could have unanticipated effects. The collider's ability to explore the Higgs boson and investigate the mysteries of dark matter, a substance that makes up a significant part of the universe, might unlock truths beyond human comprehension. While the anticipation of discovering the universe's deepest secrets is exhilarating, it comes with inherent risks. The LHC mimics the extreme conditions present at the universe's birth, recreating temperatures, pressures, and energies far beyond anything we encounter on a daily basis. It's as though we are gazing directly into the moment the universe came into being. Yet, with such colossal power comes an equally enormous obligation. Consider the 1978 incident involving Anatoly Bugorsky, a Russian physicist, while conducting maintenance on a particle accelerator at the Institute for High Energy Physics in Protvino, Russia. Bugorsky accidentally placed his head in the path of a proton beam traveling at nearly the speed of light. The beam passed through his skull, causing severe tissue damage along its path. Remarkably, Bugorsky survived, though he suffered permanent hearing loss in one ear, partial facial paralysis, and long-term neurological effects. His case became a chilling reminder of the potential dangers that arise when humans interact with high-energy particles. While the LHC is designed with rigorous safety protocols, the immense energies involved have led some to question whether unexpected outcomes could occur, ones beyond our current understanding. Among the most controversial concerns is the possibility that the LHC might generate microscopic black holes. According to certain theoretical models, when protons collide at near-light speeds, the resulting energy densities could briefly create black holes smaller than subatomic particles. Most physicists, however, argue that these black holes would be harmless, evaporating almost instantly due to a process known as Hawking radiation, named after the renowned physicist Stephen Hawking. Nonetheless, the mere concept of creating black holes on Earth has sparked public anxiety and ethical debates about the limits of scientific experimentation. Another area of concern involves the production of strangelets, hypothetical particles composed of strange quarks. In theory, strangelets could convert ordinary matter into strange matter, potentially triggering a catastrophic chain reaction. While this scenario is considered highly unlikely, it has fueled fears that experiments at the LHC might unintentionally destabilize the very fabric of the planet. CERN scientists have repeatedly assured the public that extensive safety reviews and theoretical calculations have demonstrated that such events cannot occur. They emphasize that cosmic rays, high-energy particles from space, routinely collide with Earth's atmosphere at energies far exceeding those produced by the LHC without causing any harm. Yet, despite these reassurances, the ethical implications of high-energy physics research persist. As scientists push the boundaries of what is possible, they confront questions that extend beyond physics into philosophy and morality. Should humanity pursue knowledge at any cost? Can we truly predict the consequences of experiments that replicate the conditions of the universe's birth? And if we unlock forces that lie beyond our control, what responsibility do we bear for the outcomes? Brian Cox, while expressing confidence in the LHC's safety, has acknowledged the importance of these questions. In interviews and public lectures, he has emphasized the need for transparency, rigorous peer review, and open dialogue between scientists and society. The pursuit of scientific discovery, he argues, should always be guided by ethical considerations and a deep respect for the unknown. As the LHC continues to push the frontiers of physics, its discoveries promise to reshape our understanding of reality. Yet, the machine also serves as a symbol of humanity's dual nature, our boundless curiosity and our capacity to alter the world in ways we may not fully comprehend. Whether the LHC ultimately leads to breakthroughs that benefit all of humanity or reveals dangers that challenge our very existence remains an open question, one that underscores the profound responsibility that comes with exploring the unknown. In the end, the Large Hadron Collider is more than a scientific instrument. It is a testament to our quest to understand the universe's deepest mysteries. But as we stand on the brink of discoveries that could redefine our place in the cosmos, we must also confront the ethical dilemmas that accompany such knowledge. For in our pursuit of the ultimate truths, we may discover not only the origins of the universe, but also the limits of our own understanding and the consequences of venturing beyond them. Using a U.S. synchrotron for research at the Institute of Physics for High Energy, Borsky was accidentally struck by a beam of protons that entered his skull. He managed to stay conscious and walked to get help from a doctor, demonstrating the potential dangers of particle accelerators. The power harnessed by these machines should not be underestimated. LHC-related concerns, particularly the possibility of generating black holes, although on a very small scale, have sparked fear among some scientists. Black holes are regions in space with such immense gravitational pull that not even light can escape. Some theorists have feared that a tiny black hole could be created at the LHC, one with the potential to consume Earth from the inside out. However, researchers at CERN have assured the public that any black holes formed would evaporate quickly and do not pose a threat to the planet. Still, this theoretical possibility has captured the public imagination, fueling both fear and intrigue. The idea that high-energy particle collisions could create a black hole has led to much debate, contributing to a growing understanding of the risks associated with such powerful experiments. To better understand the LHC's potential to create a black hole, it's essential to grasp the system's mechanics. When protons are accelerated to nearly the speed of light and collide, the energy produced is so immense that it distorts the very fabric of space-time, similar to how jumping on a trampoline causes its surface to bend and warp. These distortions in space-time raise an unsettling question. Could such shifts lead to the creation of a black hole? In the strange world of quantum physics, where the fundamental laws of nature often seem illogical, a theory suggests that unknown dimensions of reality may be embedded in the fabric of space itself. If such hidden components exist, the LHC might access them, potentially triggering a gravitational anomaly capable of creating a black hole. This possibility has garnered the attention of some of the world's foremost scientists, including the late Stephen Hawking. Hawking wrote about this phenomenon and cautioned against the potential dangers posed by the LHC, especially if the Higgs boson behaves unpredictably at high energies. Such an anomaly could cause a catastrophic event known as vacuum decay, which might not only obliterate Earth, but also unravel the very fabric of the universe itself. Similarly, renowned cosmologist Sir Martin Rees acknowledged the dangers posed by accelerators. In his works on humanity's future, he suggested that experiments at CERN could potentially trigger vacuum instability, an unimaginable occurrence that could result in catastrophic alterations to the structure of space-time as a whole. Yet, despite these concerns, the probability of such an event occurring remains exceedingly small. Scientists are fully aware of these risks and have implemented extensive safety measures to minimize potential dangers. However, the nature of scientific exploration means that some uncertainty is unavoidable, especially when venturing into unknown realms. The pursuit of knowledge has always involved an element of risk, but it is this very willingness to challenge boundaries that has fueled human progress. The LHC represents humanity's insatiable curiosity about the universe, a culmination of decades of scientific accomplishment. Despite the potential dangers associated with this revolutionary research, the likelihood of a catastrophic event remains low. Nevertheless, the consequences, should such an event occur, could be world-altering. As we continue to explore the mysteries of the universe, it is vital that scientists, policymakers, and the public engage in open, transparent discussions about the ethical and existential implications of these experiments. In conclusion, the Large Hadron Collider, LHC, at CERN serves as a monumental testament to human ingenuity. It facilitates invaluable scientific advancements, offering insights into the fundamental nature of the universe. However, with such extraordinary power comes a moral responsibility of equal importance. As we uncover the secrets of the cosmos, We must ensure that our pursuit of knowledge does not come at the cost of our health and safety. The LHC stands as a powerful tool in our quest for understanding, but it also serves as a stark reminder of the ethical considerations that accompany our ventures into the unknown.